We'll proceed in vector and commercial calculus. Vector and commercial calculus, very long discussion happening. And we have learned two things. We have learned two things. What two things we have learned? Okay, what we have learned is what we have learned is if if there is a two-dimensional curve, I won't say it is a circle. It is a two-dimensional curve. If it is a two-dimensional curve, then this point is any point P on the curve. This is centered at the origin. So, so this is the origin. If I take any point P here, then from origin if I draw a line, then this is called vector. This is called vector. Hup, 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 hup. What do you mean? Connecting any 2 point is a vector? Yes. Connecting any 2 point is a vector. Now, if connecting any 2 point is a vector, then connecting origin and any point P here, connecting origin and any point P here is a vector. This is called position vector of any point. Position vector means a line connecting origin and any coordinate. Origin and any coordinate. If I connect it, that vector is called position vector. So if I have this curve and it is a circle, it is centered at the origin. If I take any point P here, and from center, if I connect a line as being this is a vector, then this is called position vector. Okay, if this is called position vector, if this is the position vector, then this is one vector. We are discussing with vector and energy calculus, commercial calculus. Okay, this is curve. This is curve. This is sinusoidal curve. This is sinusoidal curve. This is any arbitrary curve. Okay, there is a curve line. If you see, a curve line is going like this, like this, like this. This is a straight line. This is one kind of a special case of a curve, and it is a straight line. Now, there is a vector that will go along the curve. There is a vector that will go along the curve. Okay, if a vector goes along the curve, if a vector goes along the curve, then at this point, the vector that go along the curve is called displacement vector. So at this point, displacement vector is tangent at that point, 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 tangent at that point. Displacement vector is tangent to the curve. Are you serious about it? Displacement vector is tangent to a line. Okay, I have a line called y equal to x. Y equal to x is a line whose slope is 45 degree and it passes through origin. Y equal to x. Now, tell me what is the vector form of the displacement vector. Displacement vector is a vector that is tangent to the curve. Okay, now this is x-axis, this is y-axis, this is x-axis, this is y-axis, this is the y equal to x line. Now tell me the displacement vector. Displacement vector is tangent to the curve. This is a curve. Tangent to the curve is every point tangent to the curve is along the line only. So what is the vector representation of tangent to the curve? That is the displacement vector, that is the vector that is along the line. So everywhere same vector will work. But if it is not a straight line, then everywhere displacement vector will be tangent at that point. So now we learned two type of vector. One is called position vector. That is a vector that is touching the curve and touching the origin. If this is the origin and this is the point on the curve, then this is called position vector. If this is the point on the curve, then vector that is along the curve is called displacement vector, and that is the tangent vector. Okay. Now, if I have a surface, if I have a surface, this is a surface, this is a 3D surface. Surface can be of two types. Surface can be of two types. This is flat surface, whereas this is a this is a curved surface. Like a curve can be two types, curve or a straight line. Curve or a straight line. Similarly, a surface can be of two types, a curved surface and a flat surface. Flat surface is a special case of curved surface. So if I say surface, surface means curved surface only. If curved surface, if I make it straight, it becomes a flat surface. Okay, now 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 consider this curved surface is centered at the origin. This ball is centered at the origin. If it is centered at the origin, the center of this ball is the origin. This is x-axis, this is y-axis, and this is z-axis. X-axis, y-axis, z-axis. In that fashion, this is centered at the origin. If I take any point P here on this surface, any point P here, from center of this, that is the origin, if I draw a line, that is called position vector. Again, the position vector definition is constant everywhere. Take any point in the space and connect from the origin, whatever vector you get, that is called position vector. So from the origin, that is the center of this sphere ball, from origin, if I take any point P and if I draw a line, then that line is called position vector. Okay, if that is the position vector, then what is surface area vector? Like similar fashion, if this is a two-dimensional, if it is a curve, and from center, if I draw a line, then it is a position vector. And another vector that is along the curve is called displacement vector. Similarly, if this is centered at the origin, from the origin, if there is a point P here, if I draw a line, that is called position vector. And then in analogous to the curve vector, displacement vector or analogous to the curve, there is a surface like this. Analogous to the curve, there is a surface like this. What is surface vector? Curve vector is tangent at this point and it is along the curve. It is along the curve. Okay. Now, if I take this surface, then what is the surface vector? Is it the vector that is along the curve? If this is the surface, okay, if this is the surface, if this is the surface, okay, if this is the surface, if this is the surface, okay, then what is the surface vector? Surface vector is it the vector that is along the surface? This is along. If surface is moving like this, then vector is also moving like this. So this is called tangent vector. Is it? Okay, in analogous to the curve, curve vector or displacement vector is a vector that is along the curve. Similarly, if there is a point P here from the center, if I draw a line, this is analogous to the curve, two-dimensional curve or line curve, that is position vector. Here also, that is position vector. But if I analogous to the displacement vector, if I'm trying to find, then along the line curve, what is the vector that is going? That is called displacement vector. Similarly, along the curve, if there is a vector is going like this, then is it called area vector? If there it is called displacement vector because that represents the line curve, then here it is a surface curve. Then surface curve, how I define the surface curve? Surface curve, can I define like this? Okay, leave it. Can I, if there is point P here, then I take a tangent vector the way I took in the line curve, tangent vector. But tangent vector can be in 360 degree. Which vector we are talking? Tangent vector is in 360 degree. Can we see? All are tangent vector. But here, if it is a line, if it is a line curve, okay, if it is a line curve, then tangent vector is not 360 degree. It is only along the curve. Only along the curve. So tangent vector is only one. Tangent vector to the line curve is only one. But if I see tangent vector to the area curve, then it is innumerous, infinite. It is innumerous, infinite. And it is in 360 degree. Hop, hop, hop. That is the tangent curve. Now, which one is the surface area curve? That is a question that is popping out. Then now, okay, let's see. Now we have found position vector, we have found displacement vector, and we are in a race to find the surface area vector. But whatever it is, if I have a position vector, if there is a point P that connects from origin a line, that is a vector. If I have a position vector, differentiation of the position vector is exactly differentiation of the position vector is actually the tangent vector. This is what the nature is. If I want tangent vector of any line curve, then differentiation of position vector. Position vector is xi plus yj dp by dx, because there is one independent component x and one dependent component y. dp by dx, dp by dx, I can do differentiation with independent component only, that is one, that is x-axis. dp by dx will give the tangent curve, that is xi plus yj, d of xi plus yj by dx, I plus dy by dxj. That will give I plus dy by dxj, and it will give the tangent curve. Now y is a function over x. Replace y with whatever. If it is sinusoidal, then d sin x by dxj. If it is a circular, then d of a square root of a square minus x square by dxj. Whatever it is. That is the tangent. Now, if I have a surface here, I take any point P, how to find surface area curve? Surface area curve, surface is two dimensional. This is the surface. This is two dimensional. I mean, surface is surface area. If we're talking about surface area, then certainly it is two dimensional. It has breadth and it has length and breadth. These are the two entities. In that sense, which one is the tangential? Okay, like if I take, consider here at this point, take one tangent surface. Tangent surface I can take, right? Tangent surface can rotate like this, whatever it is. But tangent surface I can take. So if I take if it is a surface, then there exist a tangent surface. Consider this is a tangent surface. If this was a sphere, then this is the tangent surface. Now surface it is two dimensional completely. If it is two dimensional, then there are two vectors that are involved. One vector is in this direction and one vector it is in this direction. Now I cannot say that this is my surface vector, or if this is the surface area, then someone can take other vectors also. Minimum two, or someone can think, if it is area, then minimum two vectors are there. But someone would say, no, I rotate one vector like this, full. Then there are innumerous vector that is possible, that is tangent to a point P on a curved surface. All all points are okay. This is what I am saying. If I take a point P and try to find the tangential vector here, then there will be many. If I connect all the many, then it becomes a surface. Okay, it becomes a surface. What is the surface vector? Then people said then if there are so many vectors are possible, then surface vector is a vector that is perpendicular to the surface area. The perpendicular to the, if I say that I have a flat surface that is tangent at any point, that I can find. There is a flat surface that is tangent at any point. If you get a flat surface that is tangent at any point, then this flat surface perpendicular direction is the surface area vector at that point. Okay, this is constant. If I talk about in analogous to the line curve displacement vector, then displacement vector are so many. If along the tangent of the curve, if I take displacement vector, then displacement vector are so many. If displacement vector are so many, then there is only one thing that is one in number is perpendicular to the distance. So surface area vector, the displacement vector is along the curve, and that is differentiation of the position vector. If I have a position vector, you calculate the differentiation of it. Whatever the new vector comes, that vector is considered as the vector that is along the line curve displacement. Okay. Now here, how to find a vector that is at any point perpendicular here? Okay, in line curve, I found that it tangent here, but here tangent that is constant is surface, not the line. Surface is constant tangent. Okay, but so surface perpendicular is the area vector. So area vector is a vector that is perpendicular to the a flat surface, where the flat surface is tangent at the curved surface. So this explanation you will not get anywhere. You can try. Now the question arises is how to find the kind of this tangent surface so that I get this tangent surface vector. Okay, that is the question. Now I won't go into the detail. Now if there is any point P here, if there is any point P here, if I draw a position vector from the center of it, if I draw a position vector of center of it, P vector, then dP by dx cross dP by dy, dP by dx cross dP by dx itself will be a vector. dP by dx itself will be a vector. Let's try. If position vector, if point P is x comma y comma z, and from origin if I draw this position vector, then that becomes xi plus yj plus zk. dP by dx, I plus dz by dxk. It has I component and k component. dP by dy, that is j plus dz by dyk. It has j component and k component. dP by dx is a vector which has I component and k component only. Means if this is x axis, this is y axis, this is z axis, then dP by dx will move in xz plane, x axis, y axis, z axis. This is xz plane, this is yz plane, this is xy plane. dP by dx is I plus dz by dxk. I component, k component, j component is missing. Means this vector will kind of dangle. Okay, it will dangle in xz plane. Similarly, dP by dy, it will kind of dangle in yz plane, dP by dy. Okay, anyway, what we have found is if I have a position vector dP by dx, that is one vector, that is in xz plane, cross product of the vector with dP by dy will give me the, not one, it will give me the area vector. Area vector in the sense at any point P, that is the area vector. If we calculate the magnitude, then it will give me a kind of area magnitude. And if I calculate a unit vector of it, that will give me exact direction of the unit vector. So dP by dx is a vector in xy plane. So if point P, if I cut in xz plane, if I cut like this in xz plane, it will, up, 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 up. These things I believe we have demonstrated many times. If there is any point P here, if I cut vertically, then I can cut in a XZ plane, it will resolve in a circle. If I cut in YZ plane, it will resolve in a circle. If this is XZ plane, then I can say this circle is x square plus z square equal to a square, where a is the circle radius of the circle. If this is in YZ plane, the equation of circle is y square plus z square equal to a square. If it is like this, then if I take any point P here, the same point what I had taken here, P here, same point P here, dP by dx vector will be along the, if this is P, then dP by dx will be along this curve. Similarly, if I take YZ plane, then dP by dy will be along the curve. Okay, that fashion, I have dP by dx is like this, that is hanging in xz plane. dP by dy is another is hanging in yz plane. If they are hanging in two vertical planes, if these two vectors, if these two vectors are hanging in two vertical planes, these are the two vertical planes. This is xz plane and this is yz plane. They will be tend to be perpendicular to each other. If I do cross product of these two vectors, it give me rectangular area in between. And that whatever the vector comes into the picture, that is a unit vector, that will be perpendicular to the surface, tangential surface. If this is the curve, this is tangential surface, dP by dx cross dP by dy will give the perpendicular to this. So now what we learned is that for two dimensions, this is position vector, then this differentiation of this position vector is the displacement vector that is tangent at this point. Similarly, if I have Similarly, if I have a 3D shape and if I have any point P and this is centered at the origin, from origin if I draw a line like this to point P, that is called position vector. If I do differentiation of this position vector with x and do differentiation with y, it will be again be a vector. dP by dx cross dP by dy will give me the surface area vector, not simply dP by dx. If it is line curve, then simple dP by dx will give the curve, curve, curve vector. But here dP by dx cross dP by dy will give me the surface, because we need surface vector. Okay, someone can go even in depth of that, that if this is xy plane, this is this is xy plane and this is the curve over it, then there are three components. There are two components. One is xy plane and one is vertical, that is z. Z and xy plane. Similar in same fashion, and if I have a 2D curve, there is a x-axis, there is a y-axis. Y-axis is vertical and x-axis is horizontal. Similarly, here, here the horizontal is xy plane and vertical is the z. So if this is xy plane, I'm not talking about x-axis, xy plane, then this is z. Z is dependent component and xy plane is independent component. Now to calculate the curve vector, to calculate the curve vector, we did, if this is position vector, dp by dx. Similarly, to calculate the area vector, if this is surface area and this is xy plane, to calculate the area vector, we did dp by dxy plane. Now, independent component is xy plane and dependent component is z axis. If I take any point P on the surface, then from origin, this is position vector. D position vector by dxy plane is the surface area vector. Okay, someone would say, right? No, I don't want cross product. What is cross product? I don't know what is cross product. Tell me the way, simply, very simple way you talked about here. This is x axis, this is y axis, this is position vector. dp by dx, d position vector by d independent component x-axis is the curve vector. Similarly, similar fashion, you talk here. Then here, there again two components. One is xy plane and another, if one is one is xy plane, then another is z axis. Dependent component, independent component. If someone has surface like this on top of xy plane and there is any point P here, okay, then from the origin, draw a line. This is position vector. Now, this position vector by dxy plane is the surface area vector. dp by dxy plane. dp by dxy plane can be rewritten as dp by dx cross dp by dy. Now, this should be understandable. Same thing, the analogous way we are saying. But since it is a cross product, so surface area vector will not be tangent to the surface. Surface area vector will be perpendicular to the surface everywhere. That is the difference between the curve vector and surface area vector. Anyway, now we have thoroughly covered the Cartesian coordinate system. dp by dx, d position vector by dx cross d position vector by dy, dx dy. This is the actual the kind of area vector. In similar fashion, in 2D, d of position vector, simply d of position vector is considered as the displacement vector. Simply d of position vector is called displacement vector. Okay, here again, if I see that line curve, if I have a line curve, I have a position vector P, d of P, differentiation of P, d of P is called the displacement vector. If someone says dp by dx, then he has to multiply with the dx also. Similarly, here P position vector P on the surface area, d of position vector is called surface area vector. dp by dxy plane into dxy plane is the bigger form. dp by dxy plane is also called dp by dx cross dp by dy, dxy, dx, dy. dxy plane dissociate into dx, dy. dp by dx, where position vector is xi plus yj plus zk, dp by dx cross dp by dy is minus dz by dxi minus dz by dxi minus dz by dyj plus k in bracket dx dy. This is the full form of the surface area vector. That is difference d of position vector. Okay, this is a more mature way. Now, actually, the idea was to calculate the flux. But flux is all right. Velocity vector dot area vector is the net flux that we have understood. If there is a surface and there is a fluid flowing through the surface, how much is fluid passing through the surface? Velocity of the fluid multiplied by the surface area of the surface is the volume that is coming out of the surface. Okay, velocity vector dot area vector, or velocity vector dot d of position vector of the area, or velocity vector dot dx dy minus dz by dxi plus dz dx dy minus dz by dyj plus dx dyk. This full is this full is surface area vector that we have learned. Okay, now can we talk about different coordinate systems? There are different coordinate systems also possible. Like I have a like we have given example. Okay, this is not a surface. This is an electric charge. Electric charge, very high speed charge. If I touch it, then it is giving me electric shock. This is a full-fledged electric charge. Now, it is electric charge I am keeping inside this big sphere. This sphere is centered at the origin. And inside this, at center of this sphere, I am placing this electric charge. Because of the electric charge, electric field will start generating all around, and electric field will cross this surface. How much electric field is crossing this surface? Okay, that is the flux. If I talk about the velocity vector of the electric field, then I'll give you the equation and then find out how much is the net flux that is coming out of the surface. If I say velocity, if this electric charge is generating velocity, velocity means it is because of this electric charge, a fluid is coming. Consider the electromagnetic wave as fluid. Because of this electric charge, fluid is coming all around. If fluid is coming all around, then how much is the fluid that is passing through this surface? That is the fluid velocity dot product with the area vector. Fluid velocity is q. Q is the charge. R vector divided by r to the power 3 dot product with the area vector. Now we converted everything into Cartesian coordinate system and then we proceeded with the calculation. So it becomes q, r vector becomes xi plus yj plus zk divided by r to the power 3 becomes x square plus y square plus z square to the power 3 by 2. Dot product with the surface area vector, that is dx dy minus dz by dxi plus dx dy minus dz by dyj plus dx dyk vector. Okay, if that is the scenario, calculate the cross product and you get the net flux passing through. We have calculated it and it is 4 pi q. Q into 4 pi. This is what I remember. Q into 4 pi. Now, can we try? See how difficult it is. Q xi plus yj plus zk divided by x square plus y square plus z square to the power 3 by 2 dot product with dx dy minus dz by dxi plus dx dy minus dz by dyj plus k plus dx dyk. Now, where z equal to square root of a square minus x square minus y square as far as sphere is concerned. Now, this can be better if we see. Now, anyone would be, he would start shaking. Okay, this much big equation someone solves it, you would start shaking. Anyone would say, can you try to find something simple? Okay, anyway, what is the equation of the fluid that is coming out of the electrical field or electrical field fluid coming out of this electrical charge, that is q r vector divided by r to the power 3, whereas the surface area vector is dx dy minus dz by dxi, dx plus dx dy minus dz by dyj plus dx dyk. Can you find this simple in r term only? Okay, then it will be great thing for us because this is completely in r. If you find this in r also, dot product, everything will be easy. Can you do that? Okay, we'll try a spherical coordinate system. So a spherical coordinate system, it talks about kind of three independent components. In Cartesian coordinate system, there are three independent components: x-axis, y-axis, z-axis. They are 90 degrees to each other and they are called three pillar of Cartesian coordinate system. Similarly, a spherical coordinate system has three pillars. One is called angle. Now consider this is a sphere, spherical coordinate sphere, and it is centered at the origin. If it is centered at the origin, if I think about the xy plane, then xy plane is exactly at the center. Top is top hemisphere, bottom is bottom hemisphere. And if the xy plane cuts it, now center of this sphere is origin, 0 comma 0 comma 0. Now if that is the case, there are three independent components here. One is radius. Radius is that will go from 0 and it will go bigger, bigger, bigger. The sphere will become bigger, bigger, bigger. Another is called theta. Theta means this radius in xy plane. This radius is all around. If I take radius in xy plane and move the radius along xy plane, then that angle is called theta. And if I take radius in vertical and move radius like this in vertical plane, this angle is called phi. There are three independent components, theta, r and phi. That much is available in the book. Whatever I am going to talk now, it is not available in any of the book. Why it is coordinate system? Why a spherical coordinate system is called coordinate system? Coordinate system means all three components must be perpendicular to each other. Now theta is an angle. How it is perpendicular to the radius? And phi is an angle. Phi is an angle. How it is perpendicular to the radius and theta angle should be perpendicular to the radius and phi. Phi should be perpendicular to the radius and theta. Radius should be perpendicular to the phi and theta. Then it is called coordinate system. This is something that is missing everywhere. Everyone is in mood of shortcut. Anyway, now if I take theta, this is theta angle. The angle what I am talking now, it is theta angle. Theta angle moves 0 degree to 2 pi. Phi moves 0 to pi. Okay, now if this is theta, then it makes an arc. If you see silently, it makes an arc. This arc is actual coordinate system, not the theta. That is the painful in book. They say theta is coordinate system. Actually, if you think about orthogonality in the coordinate system, then the arc that is made by the theta is actual component of orthogonality. If that is the case, then if you see the arc, then this arc is perpendicular to the radius. Okay, what is the arc? If there is radius r and angle theta, if I move, the arc length is r theta. If this theta is 2 pi, then full length is r 2 pi. So this is the arc that is moving like this in xy plane. Similarly, if I move in vertical side, then this finger is the arc. Okay, arc length is r phi. Here it is r phi and here it is r theta. Now if see this arc, this arc is perpendicular to the radius. Similarly, if I see vertical arc that is made by the phi, then this arc is perpendicular to the radius. This arc is perpendicular to the horizontal arc and this arc is perpendicular to the radius. This radius is perpendicular to the vertical arc and it is perpendicular to the horizontal arc. All three are perpendicular to each other. This is nothing but a spherical coordinate system. One is radius phi, one is radius theta, and one is radius. Can we use this concept to proceed and calculate the net flux, that is result? I know result is 4 pi. Can I proceed on this? We will try. I'm not running away. Now, if that is the case, then we will try. Now, consider what is the surface area? dP by d surface area is what is surface area? D of position vector is the surface area vector, if someone remembers. D of position vector is the displacement vector. D of position vector is the surface area vector. dP by dP. So what is the flux? Velocity vector dot product of d of position vector, or velocity vector dot product with the area vector. Velocity vector, I know it is q r vector divided by q r vector divided by r to the power 3 dot product with d of position vector. D of position vector can be written as dP by d theta phi plane into d theta phi plane. Hop. D theta phi plane. If I talk about the surface of a sphere, then radius is constant. Okay, if I talk about the surface, then radius is constant. What is variable here is any surface has two sides. Any surface has two. If I take any small surface strip out here, then it is like this. It is like this. It has two sides. One is vertical arc and one is horizontal arc that make the surface of a sphere. This explanation is not anywhere else. You can try it down. Don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number, plus 91 is the India country code. So if this is the surface, then it is formed by two arcs. One arc is the vertical arc, one is the horizontal arc. Okay, if that is the case, then if I have dp, then I will differentiate along the surface. Okay, two independent. So if I taken the Cartesian coordinate system, then dp by dxy plane, considering x, y are independent here. And here I'll take d, theta and phi, because I consider theta and phi, they are constituent of the surface. They are independent. Surface area is dependent upon theta and phi. R is constant, means the independent variable component is theta and phi. dp by d theta theta phi into d theta phi. dp by d theta cross dp by d phi. dp by d theta cross dp by d phi into d phi theta phi plane, that is d theta d phi. What is dp by d theta cross dp by d phi? Let's go with position vector p. Now p I have to demonstrate in a spherical coordinate system. If there is any point p here, then what it is in a spherical coordinate system? From the center, if I draw a line, that line is nothing but radius r, radius a, whatever it is, radius a. Okay, if this is radius a, now let's position vector was, we will move slowly. Position vector was xi plus yj plus zk. What is xyz? If I take position vector like this height is z, this height is z. Okay, if this height is z, this height falls somewhere on the xy plane, and from there x component and y component. X component is x axis, y component is y axis, and then this height is z. This height is z. How much this height is and how much the other component is. If this is r, consider this r. R has made phi angle from the vertical. If I take any point P here, from the origin, if I draw a line like this, if I draw a line like this, then this line makes phi angle from the vertical. And it is not in xz plane. It is not in yz. This is a radius. This is not in xz. This is xz plane. This is not in yz plane. This is somewhere else. If it falls on xy plane, it makes theta angle from the x-axis. It makes 90 minus theta from the y-axis. This is radius. This is point P. Now if this is phi, then P sine phi falls on xy plane. Cos theta makes x-axis. P sine phi, sine theta makes y-axis. So x equal to P cos theta, P sine phi cos theta. Y equal to P sine phi sine theta. What about height? If this is phi, if this is phi, if this is phi, then this is cos theta. If this is phi, then this is sine theta. This is r cos theta. This is the height. So r cos theta is the height. So xi plus yj plus zk becomes r sine phi cos theta I plus r sine phi sine theta j plus r cos phi k. dp by d theta cross dp by dr into d theta r plane. That is the area vector. D of r sine phi cos theta I plus r sine phi sine theta j plus r cos phi k by d theta cross d of r sine phi cos theta I plus r sine phi sine theta j plus r cos phi k by d phi, d theta d phi. Now let's solve it. Now if I do the differentiation, it becomes r sine phi minus sine theta I plus r sine phi cos theta j plus gone. Nothing. Cross product with now differentiate with the phi, it becomes r cos phi cos theta I plus r cos phi sin theta j plus r minus sin phi k. Now someone has to calculate cross product of these two, r sin phi minus sin theta I plus r sin phi cos theta j, cross product with the r, cross product with the r cos phi cos theta I plus r cos phi sin theta j plus r minus sin phi k. Whatever comes d theta multiplied by d theta d phi, that is the area vector. It looks very cumbersome, but it will resolve in simpler terms. We'll try. I'm not running away. So r r r sin phi minus cos theta I. If I do cross product on right side, I cannot do cross product. With j I can do cross product. So j is r cos phi sin theta. Here r sin phi minus cos theta. Okay, then it becomes sin theta cos theta. I'm sorry. First is r sin phi my r sin phi minus sin theta, because we differentiated with theta, and that side r cos phi sin theta, sin theta sin theta, sin theta sin theta, I and j, it cross product becomes k. Okay, and then here it is sin phi and here it is cos phi. r square r square r square sin phi cos phi minus sin square theta. Okay, this is k term. There will be another k term, that is j. Next was r cos phi, r r I'm sorry, r sin phi cos theta, r sin phi cos theta j, and there it is I, that is r cos phi cos theta. Okay, j cross I becomes minus k, and now it becomes r square sin phi cos phi minus cos square theta, minus cos square theta, because I cross j. So minus k here also, minus k here also. If someone settle down, it becomes r square sin phi cos phi, sin square theta plus cos square theta, gone. It now full it becomes minus r square sin phi cos phi k. Now this term we got r minus r square sin phi cos phi k. Now let's find other term. Now we have I component, j component. There I, j and k. I and j we settle now. I and k we will settle. Now I is r sin phi minus sin theta I, and that side r minus sin phi k. I and k, I and k, I and k becomes minus j, and then minus minus plus minus. It will come as minus 1. It will come as minus 1. Then r sin phi, r sin phi, r sin phi, r sin phi minus sin theta, r sin phi minus sin theta. There r sin phi. Okay, then it becomes r sin square phi sin theta, j r sin square phi sin theta j. Okay, let's find the I term. Then this j term and their k term will make I term. Here j term is r sin phi cos theta, and there r sin phi k. Okay, that is minus. So j cross k is I, but there it is minus, and here there is no minus. Again it will come as minus 1. Then r sin square phi, r sin square phi r sin square phi cos theta I. Okay, what we have found now, that is r square sin phi cos phi k minus r square r square sine square phi, r square sine square r square sine square phi sine theta j, and r square sine square phi cos theta I. This is the this is the kind of area vector that someone has to try. Okay, d theta dr, d theta dr. Okay, so that is the kind of integration that someone has to do. Okay, so this much we have got, that how much it is. Okay, probably we will proceed on this. So this is a spherical coordinate system. Idea is to, it is too much time now. Idea is that how it will make life simpler, but we have found dp by d theta cross dp by dr, but this is hybrid model because through Cartesian only we proceeded, and it still look tedious, right? That is minus r square sine phi cos phi k vector minus r square sine r square sine square phi cos phi cos theta j vector minus sine square phi minus r square sine square phi sine theta j vector. This is the full kind of, now I have to do cross product with this. Okay, but I have theta vector, I have I, j and k. Still I have to bring it into x, y, z only, where x I'll replace with the r sine phi cos theta, y with r sine phi sine theta, and z with r cos phi, and then we will do. Then people will say, why you did this one? Are you nonsense? It was better we did in x, y, z and x, y, z. Okay, so this is nonsense. So we will proceed on this, and we will see how it will be very much sense, and anyone would love, oh, I never thought that it can be that simple. So to proceed from here to here, first we proceed in x axis and then go like this, or Manhattan distance, or from here and there. So to directly come from Cartesian coordinate to polar coordinate, we are trying to do in between. Then we will jump into the actual, to a spherical coordinate, the actual spherical coordinate that is certainly not there in any of the book. Please consider supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country.